Coral bleaching is one of the most dramatic consequences of rising ocean temperatures caused by global warming. When corals bleach, the vibrant colours that make coral reefs underwater gardens fade. This happens when the animals that build corals are exposed to different types of stress. The main phenomenon threatening our coral reefs is extreme temperatures. In recent years, the frequency and duration of temperatures has increased, in some places resulting in widespread coral bleaching and even death. Uncontrolled carbon dioxide emissions trap heat within our atmosphere and fuel global warming. It's this build-up of heat that is now affecting a very special multi-million-year-old partnership between algae and the coral polyp animals. Coral is made up of a colony of animals called polyps. They have a symbiotic relationship with unicellular algae known as zooxanthellae. As sea temperatures change, coral polyps become heat-stressed. Their zooxanthellae are not able to properly process the light energy they usually capture, causing the energy to be passed into oxygen and forming dangerous oxygen radicals that damage the tissue of the coral polyps. The coral polyps react to this by expelling their zooxanthellae into the surrounding water. After losing the zooxanthellae, which acts as a carbohydrate-producing factory, the coral begins to starve. Within 24 hours, the entire coral's tissue can be bleached. When a coral is faced with prolonged temperature stress, its zooxanthellae can't regrow or return, and the coral polyps themselves die. Very rapidly, this vacant reefside real estate is taken over by whatever grows fastest, and this is usually macroalgae. If temperatures cool and return to normal, bleached coral can recover in time. Even in corals bleached white, some zooxanthellae remain within the living polyps and can reproduce again and recolonize the polyps, bringing life back to the colony. This is a process that has saved many coral reefs. Some coral species are better at recolonization than others. However, during bleaching events, the initial lack of nourishment will stress the entire reef. A poor reproductive cycle is almost certain for the corals that do survive, which can prevent corals from recolonizing the reef. Just as a forest may consist of trees and bushes, a normal reef has a balance of coral and macroalgae, such as seaweed. During bleaching events, this balance can be upset as the large algae that thrive in higher temperatures crowd out the corals. The loss of the primary producers from this ecosystem can cause localized extinctions of fish species, as well as impacting other species further up the trophic scale, such as seabirds. Though coral bleaching is a natural phenomenon that corals have the ability to recover from, each bleaching event weakens the overall health of the coral over time, making recovery more and more difficult. It is the increased frequency and intensity of these bleaching events that has the potential to form the basis of mass mortalities. The mass global bleaching event in 1997 to 1998 was on a size and scale never seen before. Almost every coral on the planet bleached. In some regions, 95% of all the coral were lost. In 2006, 60% of the Great Barrier Reef alone bleached. Most projections of sea temperature increases as a result of climate change estimate that these devastating events will become more and more frequent. While climate change naturally occurs on Earth, it generally happens over hundreds, if not thousands of years, and species have the opportunity to naturally adapt. The rate at which we have seen temperature change over the last 70 years is unprecedented, and if we approach levels of atmospheric carbon dioxide of 450 parts per million, we risk losing most of the ecosystems on the planet, including coral reefs.